Hi, I'm Selena Klosowski with the City and County of Denver, Department of Transportation and Infrastructure, Wastewater Management Division. We maintain sanitary, storm, and water quality infrastructure, and I supervise a small design team that helps support our in-house construction group that performs maintenance repair. Rick, would you like to introduce yourself?
Yes. Hello, Rick Abeyta, City and County of Denver, Department of Transportation and Infrastructure, Wastewater. I supervise the in-house construction group, and it consists of 3 crews and 2 locators.
Thank you for that, Rick. We are here to talk about the Urban Debris Management Pilot Program that we started over here in Wastewater Management Division. So if you take away anything at all from this presentation, take away that we are here to support you guys as a drainage design community. You can reach out to me if you have any feedback about this presentation, or if you'd like to collaborate about creating your own debris management device. We're here to help. So go ahead and jot down my email, selena.klosowski@denvergov.org, or give me a call. All right. So the pilot program, UDMP, is what we call it internally, aims to assess, implement, and monitor alternative debris management devices that reduce trash load on our waterways and rivers. So across Denver, we're actually putting in a lot of trash debris management devices, trash collection devices to help the environment and make sure that we're minimizing the amount of trash loading that's actually coming into our waterways. And one of the most important things that we do is maintain these facilities. So what we're doing here in wastewater management is really to make sure that we are reaching out to this community to help provide some guidance. And collect based on actual data that we're collecting. So one of our deliverables is actually to provide a guidance document for the design engineers for their debris management solutions so that they are maintainable. So in this guidance document, this is all very preliminary, but what we're planning on putting in is a list of equipment that we have here in wastewater, and also maybe some preferences, like what type of pieces of equipment that we'd like to deploy, such as a back truck or something like that. We'd like to also include some design suggestions, such as offline, installed at a drop. We want to also have you guys help us standardize. So some design suggestions may be, make sure you include this type of configuration or that type. And we also love some feedback as well. If you're taking notes of what works and what doesn't work, this would help that section. We'd also suggest that you consider dry weather flows itself, because dry weather flows can actually make it very difficult to maintain because of all that water that we have to keep up with, especially if we're deploying a back truck. It's very difficult for a back truck to keep up with those dry weather flows. Another thing that we might include is a list of criteria for decentralized devices. So what I mean by that is if you've got a trash bag within an inlet, we might put in, this is how much clearance we want from the throat of where that trash bag starts, things like that. Possibly, we might even include a conclusion on our preference as to whether we prefer maintaining decentralized or centralized devices. We would need to include quite a bit of data in order to make that type of conclusion, so that's definitely tentative, as along with the rest of this outline. So what I mean by centralized devices, I mean trash vaults, so outfall nets, those kind of things. So some of the trash vaults that we have, the City and County of Denver have actually constructed. One is in City Park Golf Course that was built in 2018, another in Sanderson Gulch that was built last year. And as a part of this pilot program, we actually built our own at Denargo and Arkins, which Rick will talk about a little bit later. So decentralized devices, what I mean by that is inlet bags, hydrodynamic separators, those kind of things. And here's a few pictures of the different type of devices right here. So timeline, we started this program about a year ago, and we enlisted our staff engineer, Kevin Monowick, and he did quite a bit of research on all the different type of debris management devices out there. And through a process of approvals through our management, we decided on piloting our own. We do realize that there was quite a bit out already implemented and built, but we really wanted to kind of experience that whole design process and construction process so that we could provide the best type of guidance for you guys and also other municipalities. So we settled on two, one decentralized and one centralized. So we decided that we wanted to build our own trash vault itself, and we installed a few bags over on Evans. This year is all about monitoring and data collecting, and also cataloging the existing debris management devices and keeping track of the maintenance of those. So that's what this year is all about. So by the summer of 2021, we're hopeful to actually get a draft guidance document. And again, as I mentioned, we would love an opportunity to collaborate with private and other public entities to create that draft. And then moving on, this doesn't necessarily have a deadline, because the more time we have, the better this document is going to be and the better resource we can be to you guys as well. So our plan is to continue this program as long as we have to. So I did mention earlier that we settled on the one pilot, which was the trash vault. So there isn't necessarily a book off the shelf or a manual or anything like that that says, all right, you got X basin, you got this land use or this type of land use within that basin, and boom, this is how much trash you're gonna get. We're all just kind of, trying to make this stuff up as best as we can. So just some acknowledgments on our planning, Kevin Monowick and also Raul Rodriguez that helped decide on what type of criteria we would use to actually select a location to build this trash vault. So Kevin actually used street sweeping data to create our own heat map. The correlation being that high volume of street sweeping actually related to high volume of trash. So we used that information. We also wanted to pick a large pipe size with a large basin, hoping that it would produce quite a bit of trash as well. We wanted to also select a pipe that had a grade differential change, or at least maybe even a drop manhole, to minimize any type of impact to the hydraulic grade line. And then we wanted to select a spot that didn't have any dry weather flow. Because we had the entire city, we could choose where we put our vaults. Not everyone can choose that, so again, just be mindful of that when you are installing your vault to check for that. And then we wanted to make sure that we had the proper pipe material and also condition of the pipe. So whenever we did tap into that existing pipe, that it wouldn't compromise the structural integrity at all. So if we chose like a brick pipe or something like that, that would be a little bit more difficult to actually construct. We wanted to make sure that our construction crews had a good site that was easy access and minimal traffic disruption, because this is the first time that our in-house construction crews was going to be building something of this magnitude, a trash vault that was 16 foot by 8 foot wide, and it's about 20 foot deep, which Rick will talk about in more detail later. Once we gathered and kind of selected a site, we went out and did some field observations to confirm whether it was trashy. So we went out and looked at the outfall, and sure enough, we found that at Denargo and Arkins, right here, we found a site that met all of these things. So Denargo and Arkins was in the red area on the heat map, had a large pipe size with a large basin. It actually had a drop manhole. Kevin actually sifted through quite a bit of as-built drawings that we had here in the office, and he found a drop manhole. So we found a place that had a 66-inch pipe and a 54-inch pipe. So we could actually draw the trash from both of these large pipes. We also found that the 66-inch and the 54-inch were both in good condition. This particular area, it's kind of low traffic. It's not like Colfax or Brighton Boulevard or anything like that. So it'd be a perfect site for our in-house construction crews. We also did confirm that it was trashy. So I mentioned that we did in-house design on this because we wanted to experience that firsthand. So credit goes to our lead designer, senior engineer Mark Gerke, who came up with this design. We wanted it to be offline. The lower flows would be taken off into this 24-inch pipe, then diverted into the trash vault along with the 54-inch, and then with gravity flow through this and into a 30-inch pipe and back into the 54-inch pipe. Because we had that drop, we were able to do that. So in this design, we followed Mile High Flood District trash rack guidelines. So we designed for an overflow. We also drained the trash rack so that the whole vault could be completely drained. So the trash rack doesn't actually go all the way to the bottom of the concrete vault. It has a gap, about a 1-inch gap. So that's to help promote a drained bottom to reduce the risk of transmission of disease pathogen from vectors such as E. coli. We also spent quite a bit of time and effort on placing our manholes. Right here, there are these long rectangular things. They're supposed to represent our vac hose. So that's the reach of our vac hose. And the way that we placed our manholes, you can park a vac truck and then go to every corner of this trash vault. So you should be able to clean the entire thing without sending someone down with a confined space. So that was really important for our maintenance crews to be able to achieve. Also, the frame design, a credit to Mark. If we had any issues with the trash rack itself, say we wanted to swap it out or there was an issue with it, we actually put them into different segments so that they could be removed and then replaced easily through the manholes. So there's no hatch necessary to perform any type of structural repairs or even to access for maintenance. All right, and with that, I am going to turn it over to Rick to talk a little bit more about the details of construction.
Okay, thank you, Selena. That was really cool, and that design. Now I got the fun part to build it with our own in-house crews. It was really fun and challenging. So here we go, construction. First thing I said is, wow, 20 feet deep, that's really deep. We don't have an excavator to go that deep. So I went to Wagner and rented this Cat 245 track mounted excavator. Dig to about 23 feet. A really big piece of machinery. I also had to get this big piece of machinery rented to drive in our shoring system, what I'll talk about in a moment. Our challenges in planning: 20-foot deep excavations, unstable material in the middle of the roadway, contaminated soils as the area was once a landfill. It's in an RTD bus route. Denargo Market Business District is in the area. Connecting large diameter pipes to existing manholes at very deep, dangerous depths. Setting heavy precast concrete. Picture here is the excavator, and we got started with our excavation there. We were able to shut down this portion of Denargo right here where the vault was to be constructed. We were able to reroute traffic on Arkins Court down 29th and then down Delgany Street, then back over to Denargo. That way, traffic and buses can get on over to Denver Union Station, waterway. So we were able to do this. We realized that Delgany Street was a private street owned by the Denargo Market Business District. So Mark Gerke and I went down to a board meeting and showed the board our plans and described to them what we were going to do, how long it's going to take, and we were granted permission to get this road closure. Construction challenges and our solutions. Depth of the excavation. I determined we should use slide rail shoring. I thought that would be the only safe way to excavate and shore up, protecting our crews at these depths. Existing material consisted of contaminated material that had to be manifested and disposed of properly. I had to work with Denver Department of Public Health and the Environment to set up an account at the dump and get this stuff manifested and hauled off site. And coordination with RTD, since we interrupted their bus routes, and the Denargo Market Business District. We selected the shoring because we were able to obtain the geotechnical report for the adjacent development that just so happens to be constructed adjacent to our trash vault, multi-family apartment building. Got the geotech report, looked at it, noticed that we have from 1 to 15 feet, we have variable soils, debris, and contaminated. All that material had to be hauled off. From 15 to 40 feet, I see poorly graded sands with no clay, little silt, meaning very unstable, very loose, very tough to shore up. So this was another reason for us to use slide rail systems for this vault. Here's, next thing was mass excavation and haul off. We used our big rented excavator and our own trucks to remove the material and haul it off to Denver Arapahoe disposal site. Here's the slide rail going in, short little video, excavator, banging the vertical rails in. Most important thing with this type of shoring is square and plumb. So we kept the rails plumb with levels. We kept the shoring square by the use of string lines, trigonometry, right triangles, whatever we can do. We found that we really did a decent job of installing the shoring, since when it came time to remove it, the rails came right out. The slide curtains came right out. They were not kinked or binded in any way because of the method of keeping it square and plumb. So that's very important when you're doing slide rail, square and plumb. Here's just another shot of the slide rail going in here. We have all 4 rails in. We're utilizing one of our cat backhoes to, hold up some of these side panels. We're using the big excavator there to plumb up the vertical rails. We got the slide rail in, excavations to depth. You see on the right side of that left picture, we have some sheet piling in there, and we were able to put in there so that way we have access holes for our pipe penetrations. You can lift up the sheet piling, top a pipe, come through the lockouts in our precast to connect. Photo on the right is just 12 inches of 3/4 inch rock bedding, compact it and consolidate it with a vibratory plate compactor. Ready to set the vault. Now, NC precast, cast our vault, 110-ton crane setting precast concrete. The vault itself consisted of a base, 3 wall sections, and a top. Here we are setting the last wall section of waterproof type joints with using ram neck between each section of precast. Again, we have to make sure things are straight, plumb. Got the slide rail in there, and it's very safe at this point. 110-ton crane setting. The wall sections were 27,500 pounds. Okay, lateral pipe connections. 30-inch diameter cores were having drilled through 2-foot thick manhole bases. 1 30-inch diameter core and a 1 24-inch diameter core. I'll never forget, it was Christmas Eve. I scheduled concrete coring company to come in and core this hole. And this guy was down there 20 foot deep in shoring, coring through 2-foot thick concrete. And he looks up at me and says, "Do you have anything like this scheduled for New Year's Eve, Rick?" I felt so bad. But we did it, got it done. One of these cores took a day, and the 30-inch core took a day and a half. This is the 30-inch on the left, and the 24-inch core took a day. And photo on the right shows a reinforced concrete pipe connecting to the existing structures with reinforcing steel hoops and structural concrete for a collar. Protect those collars because we were into freezing temperatures at this point. All right, we got 3 laterals in. We have a 24-inch lateral from this manhole intercepting the 66-inch pipe that goes into the Platte, connected into the vault. We have 54-inch new manhole set and connected into the vault here, diverting low flows into the vault. And then we have 30-inch pipe connecting into the existing drop manhole here and out to the Platte River. Clean select fill was supplied by the Central 70 project. They provided 650 cubic yards to this project at no cost, delivered it to us. We compacted it, placed it. So that was a good deal and a great cost savings. No trucking, no material purchasing. It was all clean fill, certified by the state. Picture on the right is our own Denver Department of Transportation Infrastructure street maintenance teaming up with us to make this project a success. Installed 130 tons of asphalt pavement, 3 lifts, 12 inches thick. Got that laid down and striped by Denver Traffic Operations. It was a team effort here. Here we go. DOTI Wastewater Master Tradesman Scott Ramage installing custom grading, collect the trash. Here's a shot on the left of the stainless steel grating being welded and set in. We made it so that these grates are removable. We can pull them out, clean them if we had to, replace them, do whatever we want with them. They're in a little slide system that can be removed. After a dry summer, we weren't getting much rain, but on July 15th, we knew there'd been some rain in the area. So Mark Gerke and I went out and got Saul and Adolfo out there, and we put some cones out, put a truck out there, opened up the vault, and we found that it's working very well. It's collecting plenty of trash there. As you can see, the top of the grating is left open in case of a huge storm or in case the grating getting clogged. It would end up going up to this elevation and spilling over unscreened. Okay, here's a total trash vault cost and duration. Had labor costs of $101,800. Equipment, $70,257. Material costs, $56,597. We did have some subcontractors, Winslow Crane, Kumar and Associates for testing, and Geotech, and Winslow Crane and Concrete Coring Company to core in the large diameter holes into the concrete. Total cost under $250,000 with $233,918, saving the city and taxpayers money by performing this work. In-house design, in-house construction. I guess lessons learned, don't make a big hole in the street during the winter. We did get an early winter start in the middle of October last year. Began construction October 15th, 2019 and completed January 21st, 2020. And here's a little shot on our right of our Lucity work order. We tracked all our costs in Lucity daily. Every single labor hour, every equipment hour, every subcontractor cost, every material cost is all tracked in Lucity, our asset management system. All right, I'll give this back to Selena.
All right, thanks, Rick, for that. And again, I just want to kind of reinforce, if you have any questions or feedback or want to collaborate or share data, we would love to get some data. Contact me at selena.klosowski@denvergov.org or give me a call. Thanks for tuning in and enjoy the rest of the conference.
Thanks.